Hope everyone is doing great. Today I'm going to show how to design Microstrip Patch Antenna in CST Microwave Studio. So let's start. Here is one of the websites where most of the time I use to calculate the parameters for Microstrip Patch Antenna, and it's one of the wonderful sites, everythingrf.com. Okay. Uh, I'm going to design it on the Rogers RT500, and its strength constant is 2.2. And let's say dialect it is one. I'm going to design for 25 gigahertz stuff. So here's the width and the length. It calculated for my microstrip patch antenna. So you can calculate it manually, but it's quite handy to use uh, these calculators. Let's go to Microstrip Studio. Let's go and antennas, and then I'm going to design patch antenna, and then going to use frequency domain solver. Yeah, let's go for 15 to 35 gigahertz per instance. It's random one. I'm going to create a substrate uh, on which we can model this page, right? So its length should be higher than this page. So first the width is 4.7 and the length is 3.3, and I'm going to create like maybe 646 substrate. Let's go over it like minus x by 2. So x by 2 minus 4 by 2 into 4 by 2 is two substrate thickness. We need to go for RT5 tablet here. You can see the epsilon here is 2.2, which I have used for the calculations. Okay. That's the x is going to be 6. That's the y. I can go for like 5. And yeah, straight thickness. I can go for what I have selected over here. 1 mm. Okay. So I'm going to create the ground again. Uh, minus y by 2, y by 2, 0 to 3. We have to create the ground here. So just what I am creating. That should be the minus t. The bottom of the substrate. And it should be the copper. Yeah, it's 35 micrometer or 0.035 millimeter. Okay, so I'm going to design the patch. 4.74 and 3.33. Just 4.74 and 3.33. I'm using these variables because it's easy to go for the parametric sweep or optimization with these variables. However, if you are going to use exact number, it's gonna be very hard for you at the end when you have to change the parameters. For instance, I'm going to show you at the end. Sometimes the peak you desire to operate some antenna at 25 gigahertz, but uh, its operational band is not what you have designed for. So you have to go for parametric sweeps. Okay, it's 4.7, right? 4.74, 3.33. Okay, that's okay. Going to create a stuff that is going to use for the feed. Okay, let's create another variable. Divide, for instance, 0 to maybe minus minus 2, 2, 0. Okay. 2, 2, 2, 2. That's constant. Let's add this one. 8 is 2. Get port here. Just press F, or you can go here to pick the pass here. So click the pass. Now I have to go to create the port. I'm going to macros. Then going to solvers. I have to go to solvers, right? Results, solvers, then ports. Calculate. So you have to go here, right? Calculate port extension coefficient. Okay. Calculate 6.9. Okay. Sometimes it's not going to work. It's going to give you a range. So you have to change the width or uh, maybe height. So you have to be in that one. In that case, it's worked. So I'm going to create it. Okay. So for instance, I am going to create CD radiation pattern. The far field is 25 gigahertz for instance. Okay. And have created a monitor for the far field analysis. Now let's start. The simulation is completed, so here are the S parameters. So, so you can see the S parameter should be less than um, minus 10 dB to have better value of VSWR. In this case, at 25, it's approximately 6.2 or 6.1, between 6.1, 6.1 dB. So, so if you want to improve the S parameter, you could go for optimization. For that, what you can do, you can uh, you can do optimization or maybe parametric sweep on substrate thickness, on the length and width of the antenna, and maybe on the feed as well. And in addition, if you want to improve the gain. You can give a grid between here. Most in most of the page antenna, you are going to see these grids here, or maybe you can create some slots here to improve the gain of the antenna. So how you can go for parametric sweep? You can go here, new sweep. You can, for instance, if I want to go for the parametric sweep um, on the substrate thickness, and I have some specific values of the substrate thickness which is available in the lab. So what I can do, I can go for arbitrary points. Like for instance, in my case, I have 1 mm substrate, 1.5 mm. I have 0.8 mm. So now, then this is how I can go for this parametric sweep and can check the results. Since I have already defined the far field monitor here, so I'm going to check the gain here. So one thing you are going to notice that if S parameter is going to be improved, then the gain would be comparatively less. Since the S parameter is at minus 6 dB approximately, so that's why the gain is quite high. If it's gonna be like less than minus 10, the gain will be comparatively less. And you can see here the maximum gain is 9.78 dB.